In the previous activities, you worked with variables that stored a single value at a time, a string, a number, or a boolean. In real-world cybersecurity and automation work, you will almost always need to handle collections of data. For example, you might want to store a list of IP addresses to scan, a list of open ports returned by a tool, or a set of configuration parameters for a script. Python provides powerful built-in data structures to handle these situations. The two most essential ones at this stage are lists and dictionaries. Mastering them is not optional. Every serious Python script for security automation relies on them. A list is an ordered collection of elements. You create a list by placing values between square brackets, separated by commas. For example, IP_addresses equals 192.168.1.1, 192.168.1.2, 192.168.1.254. This list contains 3 string elements. Lists can hold any type of value: strings, integers, floats, booleans, or even other lists. You can mix types in a single list, although in practice it is cleaner to keep elements of the same type together. Open_ports equals 22, 80, 443, 8080 mixed equals admin, 80, true. Lists are ordered, meaning that the position of each element is fixed and meaningful. The first element is at position 0, not 1. This is called zero-based indexing and is critical to understand to avoid common bugs. Print IP_addresses 0, hash prints 192.168.1.1. Print open_ports 2, hash prints 443. You can also use negative indexing to access elements from the end of the list. The index -1 refers to the last element, -2 to the second to last, and so on. Print open_ports -1, hash prints 8080. You can access a range of elements using slicing. The syntax is list start end, where start is included and end is excluded. Print open_ports 1 to 3, hash prints 80, 443. Lists are mutable, meaning you can modify them after creation. You can change an element by assigning a new value to its index. Open_port 0 equals 21. Print open_ports, hash prints, 21, 80, 443, 8080. Python provides several built-in methods to manipulate lists. Here are the most important ones for your automation scripts. Append value adds an element to the end of the list. Open_ports.append 3306 hash open_ports is now 21, 80, 443, 8080, 3306. Insert index value inserts an element at a specific position. Open_ports.insert 0, 20 hash inserts 20 at position 0. Remove value removes the first occurrence of a value. Raises an error if the value is not found. Open_ports.remove 21. Pop index removes and returns the element at the given index. If no index is provided, it removes the last element. Last equals open_ports.pop. Lenlist returns the number of elements in the list. This is not a method of the list object but a built-in Python function. Println open_ports in operator checks whether a value exists in the list. If 80 in open_ports, print HTTP port is open. Sort sorts the list in place, modifies the original list. Open_ports.sort sorted list returns a new sorted list without modifying the original. Sorted_ports equals sorted open_ports. Looping over a list is extremely common in automation. You use a for loop to iterate over each element. For IP and IP_addresses, print scanning plus IP. This pattern is the foundation of almost every security scanning script. You will loop over a list of targets, perform an action on each one, like launching a ping or a connection attempt, and collect results. You can also use the range function combined with len to loop with an index. For I in range len IP_addresses. Print stri plus IP_addresses I. Lists can be built dynamically. A very powerful Python feature is the list comprehension, which creates a new list by applying an expression to each element of an existing list or range. Ports_above_1000 equals p for p in open_ports if p greater than 1000. This creates a new list containing only the ports greater than 1000. This is much more concise than writing a full for loop with an append statement. Now let us move to dictionaries. A dictionary is an unordered collection of key value pairs. Instead of accessing elements by their numeric index, you access them by a unique key. You create a dictionary using curly braces. Host_info equals IP:192.168.1.1. Hostname, gateway. OS, Linux. Open underscore ports, 22, 80, 443. Each key must be unique within the dictionary. Keys are usually strings, but they can also be integers or other immutable types. Values can be anything: strings, integers, lists, or even other dictionaries. You access a value by its key using square brackets. Print host underscore info IP, hash prints 192.168.1.1. Print host underscore info open underscore ports, hash prints, 22, 80, 443. You can also use the get method, which is safer because it returns none or a default value you specify, instead of raising an error if the key does not exist. Print host underscore info dot get MAC underscore address, hash prints none. Print host underscore info dot get MAC underscore address, n/a, hash prints n/a. Dictionaries are mutable. You can add or modify entries simply by assigning a value to a key. Host underscore info status equals up. Host underscore info OS equals Ubuntu 22.04. You can remove an entry using the del keyword or the pop method. Del host underscore info hostname removed equals host underscore info dot pop status. To check whether a key exists in a dictionary, use the in operator. If os in host underscore info. Print host underscore info OS. Dictionaries have three important methods for iteration. Keys returns all the keys. Values returns all the values. Items returns all key value pairs as tuples. For key in host underscore info dot keys, print key. For key, value in host underscore info dot items, print key plus colon plus str value. In a cybersecurity context, you will often build a dictionary to structure the results of a scan. For example, after scanning multiple hosts, you could store everything in a list of dictionaries. Scan underscore results equals IP colon 192.168.1.1, open underscore ports, 22, 80, status, up. IP colon 192.168.1.2, open underscore ports, 443, status, up. IP colon 192.168.1.3, open underscore ports, status, down. This structure allows you to iterate over all hosts and access their properties by name, which makes your code readable and easy to maintain. For host in scan underscore results. If host status equals up. Print host IP plus is reachable with ports plus str host open underscore ports. This is a very typical pattern in automation and reporting scripts. It is also important to understand the difference between lists and dictionaries at a conceptual level. Use a list when you have an ordered sequence of items of the same nature, and when the position or order matters, for example, a list of IP addresses to scan in order, a list of commands to execute in sequence. Use a dictionary when you need to associate named properties with an object, or when you need fast lookup by a meaningful key, for example, mapping a hostname to its IP address, storing the results of a scan per host. Another common data structure worth knowing at this level is the tuple. A tuple is similar to a list, but it is immutable. Once created, its elements cannot be changed. You create a tuple using parentheses. Coordinates equals 192, 168, 1 protocol equals TCP 443. Tuples are useful when you want to group related values that should not change, such as a host port pair or fixed configuration values. They are also used when a function returns multiple values. Def get underscore connection underscore info. Return 192.168.1.1, 443. IP port equals get underscore connection underscore info. This is called tuple unpacking and is a very clean Python pattern. Finally, you should know about sets. A set is an unordered collection of unique elements. You create a set using curly braces or the set function. Unique underscore ports equals 22, 80, 443, 80, 22 print unique underscore ports, hash prints, 80, 22, 443, duplicates removed automatically. Sets are particularly useful in security scripting when you wanted to duplicate results, for example, removing duplicate IP addresses from a scan output, or finding ports that appear in two different scan results using set operations. A equals 22, 80, 443, set underscore B equals 80, 443, 8080, common equals set underscore A and set underscore B hash intersection, 80, 443, all underscore ports equals set underscore A, set underscore B hash union, 22, 80, 443, 8080, only underscore and underscore A equals set underscore A, set underscore B hash difference. 22. These operations are powerful tools when comparing scan results over time or across different tools. To summarize the key points covered in this lesson. A list is an ordered, mutable collection accessed by numeric index, starting at 0. A dictionary is a mutable collection of key-value pairs, accessed by unique keys. A tuple is an ordered, immutable collection, useful for fixed groupings of values. A set is an unordered collection of unique elements, useful for deduplication and set operations. Lists and dictionaries can be combined, lists of dictionaries, dictionaries with list values, to represent complex structured data. Iteration with for loops over lists and dictionaries is fundamental to any automation script. Built-in methods such as append, remove, pop, get, keys, values, and items are your primary tools for manipulating these structures. These data structures are the backbone of any Python script used in security automation, from storing scan results to parsing command output, which you already practice with subprocess, and later manipulating responses from web services and application programming interfaces.